Right. My voice was not recorded. I was discussing that when you are considering the within analysis, it means that you are considering a single country analysis in different years. When you are considering the analysis between two countries, it becomes between analysis. And when you are considering the analysis for all countries, it becomes the overall analysis. So in case of panel data, you would find these three terms repeatedly in their analysis procedure with overall, with between, and with within. So in case of within, you are considering these values or variation between years to year. Uh, uh, in case of between, you are considering these values between country to country variation. So in case of overall, you considering the values in all the countries and in all the years. So this is the basic difference. So type of panel data. There are basically two types of panel data. It is very important for your understanding because it will let you know how will you design your panel data analysis. So these are two types. You may have a short panel where entities are large and time periods are few. So it means in case of short panel, in case of short panel, you may have large amount of entities and you may have less amount of time period. Time period is less than number of entities. Let's suppose you may have uh, 20 country data with 10 years time period. It is a panel, but it is a short panel because we have more country, but we have less time period. In that case, it is considered short panel. So N mean country here because it is basically the entities. Entities. So N means entities or countries and time period means T. So when your time is less than your number of entities, it becomes short panel. So you need to understand what does it mean by short panel in order to decide the analysis procedure. Then there is a long panel. It is a reverse of the previous one. You have many time period, large T, and but you have few entities. So it is the reverse of our previous part. So in case of long panel, in case of long panel, you may have n less than t. It means time period or t is greater than number of entities or n. So we may have 10 country data with 20 years time period. So this is considered as a long panel. Now, uh, let me tell you why I have differentiated both of these. If you notice in case of short panel, the number of countries are more than time period. In this case, there there might be country fixed effect because there are more countries than time period. So there might be country fixed effect because each country is different from the other in terms of their culture, in terms of their currency, in terms of their economic values, GDPs, and so on. So each country is different from other countries. As there are more countries in short panel, so there might be a country fixed effect in that case. But if we notice here, we may have more time period effect here. So we can say that there might be time period effect in this case. So, what we have learned here that there are two types of or there are two categories of panel data. One is long panel and one is short panel. So, accordingly, a short panel data set is wide in width. It says that your width is wide. It means you have more cross sectional and you have short length in time. So this type of data is also considered wide. So we may write here wide data. All right. So next is whereas in long panel, there is a narrow in width. So in case of long panel, you have more time period. So it is narrow data. Now, this is the basic things that you need to understand. Both too small n type 1 error and too large n type 2 error problems matter. So in case of small n, there might be type 1 error. Small n. Small n is where? Here is the case of small n. You may have type 1 error. And in case of large n, you may have type 2 error. So that is the basic thing that you have to understand here. So researchers should be very careful, especially when examining either short or long panel. So this is the first thing that you need to remember because when we are going to analyze the data, we need to understand first whether our panel is long panel or short panel because there are something very serious to understand before analyzing the data. The second consideration that you need to understand is the difference between balanced versus unbalanced panel data. You may have heard about this procedure. In balanced panel, all the entities have measurement in all time period. So let's take a look over here. If we have 20 countries and all the 20 countries have these 10 years time period data, it means a balanced panel. In case of unbalanced panel, the countries may not have the 10 years time period data. Some countries have 5 years time data. Some countries have 10 years time period data. Some countries have 15-year time period data. And some of the countries may have 20 years time periods data. So when the data is not available for the same time period for all the countries, it becomes unbalanced panel data. And when the data for all the countries available for all the years or all the same year, then it becomes the balanced panel data. So you need to understand the difference. In contingency table, it is a cross tabulation or cross tabs of a cross-sectional and time period variable. Each cell should have only one frequency. Therefore, the total number of observation in NT, this tutorial document assumes that we have well-organized balanced data. So we assume here that we might have some balanced panel, but sometimes we do not have the balance panel. Then what to do? What are the complexities related to those panels? So when each entity in data set has different number of observation, the panel are not balanced. Some cells in the contingency table have zero frequency. These discussions are not relevant. So unbalanced panel data entails some computation and estimation issues. That is the important thing that you need to understand that in case of balanced panel, we may have favorable circumstances with the analysis, but in case of unbalanced panel, we may have some computation and estimation issues Although most software packages are able to handle both balanced and unbalanced data. So in Stata is a software which can accurately estimate the balanced and unbalanced panel data. So we don't need to worry about it. The next thing is fixed versus rotating panel data. This is another category that you need to understand. If the same variable or entities are observed for each period, the panel data set is called fixed panel. It means you are going to repeat the same entities in different years. So it is called the fixed balance panel. If a set of individual changes from one period to another, the data set is rotating panel. That is also the pooled panel. So I would like to exemplify this. For example, if I have a data, like I would like to show you, I need to create a table like this. For example, this is the table. I have a number of countries. I have number of years. I have a dependent variable. Let's suppose it is FDI. I have independent variable, for example, GDP per capita. I have financial development as a FD. So let's suppose my country is repeating in each year, like Pakistan, again Pakistan, again Pakistan, again Pakistan. In the year, for example, 2020, 2021, 2022, and 2023. Now, the same country is repeating in each year. This is called fixed, fixed and balance panel data because the data is provided in each year for the same country. But in case sometime we have a data where the entity does not repeat again. For example, we may have data for Pakistan in 2020. We may have data for India in 2021. We may have data with Bangladesh with 2022. We may have a data for Afghanistan for 2023. It becomes basically the rotating panel. So in case of fixed panel, we may have observation or entities that is repeating again and again. While in case of rotating panel, the individuals or entity changes from one period to the next. That is rotating panel. So we assume that we have a fixed panel. The entities are not repeating. So the first thing that you need to do is to consider the long panel versus short panel in the data set. And we may have a lot of commands here. I will let you know tomorrow what kind of things that we can consider with the panel data. So I will share this particular document with you so that you can repeat a lot of things from here. So let's consider the basic of panel data model for today's discussion because we have a short time for this session. We may have the panel data models like we may have pooled OLS. There are some assumptions relating to pooled OLS. We may have, if you remember, we may have a different kinds of static panel techniques. Like I would like to show you. Yes, this one. We may have pooled OLS, we may have random effect, and we may have fixed effect. So there are different assumptions when we can apply the pooled OLS, when we can apply the random effect, and when we can apply the fixed effect. So there are some data analysis technique and as well as some assumptions that we need to consider. If individual effect, like your cross-sectional effect or time specific effect does not exist. If you assume that there is no country effect or no time series effect, like I have told you here, in this case, there might be some country effect, there might be some time period effect. If we assume that there is no entity effect and there is no time period effect, then we should use the pooled OLS, because it assumes that no such effects are exist. So in this way, we can use pooled OLS because we assume that there is no specific country or specific time period effect in that case. So these are the assumptions. The linearity assumption, there should be a linear relationship between the IV and DV. There should be exogeneity. It means there should be no correlation between independent variable and your error term. Like I have let you know the exogeneity or endogeneity concern. Then there should be no heteroscedasticity. There should be no autocorrelation, and there should be no specification error or functional issues. So if these conditions are met, we can use the pooled OLS regression. The first thing is that we are not assuming any cross-sectional or time period effect. And second thing, that we need to meet these assumptions. If these assumptions are violated, we cannot use the pooled OLS procedure. So this is how we can consider the pooled OLS. The next thing is when we can consider the fixed or random effect. There are certain assumptions with fixed effect and random effect. If we assume that your uh, your fixed effect, your country specific effects or your time period effects, they are basically considered in with reference to your alpha or beta naught value, like this. This is the beta naught. If your country specific effect or if your time period effects are basically related to your beta naught, then we might be using fixed effect regression model. But if you assume that your country specific and time period effects are related with error term, then we are going to use the random effect. This is the basic difference between both of them. So in case of fixed effect model, your fixed effect like this, you can see A plus UI. UI is the country effect or cross-sectional effect or time period effect, and it is basically related with your beta naught or alpha. While in case of random effect, your country effect or time period effect is relevant to your error term. That is why UI plus VIT. VIT is the error term. So this is the basic difference between these both concepts. So as the today's time is over, you need to read this document. I will share some research paper with you, and tomorrow I will let you know how to apply the basic consideration of panel data model, how to apply the step-by-step procedure in panel data modeling, and I will discuss some more detail about the basics of panel data so that you can understand more deeply how to correctly apply the panel data analysis. So if you have any question, you can ask. Do you have any question, Adnan, Afzal, or Waqar? Please let me know if you have any question you want to ask, or we can conclude the session because there is a time to end the session. So please let me know, Adnan, Afzal, if you have any question.
Assalamu alaikum.
Walaikum.
Brother, as you told us that the correlation between IV and error term, that
Mhm.
problem is endogeneity.
Yes, yes.
In order to fix that problem, we use always a dynamic panel model.
Yes, there are certain procedure. we can use preferably the GMM technique in dynamic panel model, but we can also use the 2 SLS or 3 SLS method as well, if they are proved to be more reliable or more accurate one. We may have certain techniques, like I have shown in my contents. We can use the SLS technique, we can use the 2 SLS, 3 SLS, but most of the researcher use the GMM technique like difference GMM, system GMM to control for endogeneity. So we have a number of options, but preferably most of the researcher use system GMM and difference GMM.
And when we use a GMM technique, we always use a lag value of dependent variable as our IV.
No. If we would be able to find out some endogeneity variable in our model, for example, I have told you that this is the issue with IVs, whether they may be omitted IVs or whether they may be the given IVs. If the given IVs prove to be endogenous in our model, then we don't need to use the lag value of dependent variable. But if we could not find any independent variable in the existing model who is influencing your error term, then in that case, we consider that it might be some omitted variable in the model that is influencing your DV. Then in that case, in case of variable emission, we may consider the lag value of dV as the omitted IV, and we will resolve the endogeneity issue with this in case of variable emission. But if there is no variable emission, then you may consider the existing IVs
मैं
as
जानता
a endogenous variable.
हूँ।
Any other question?
Thank you. Thank you.
All,
Thank you.
all right, all right. Thank you. Stay blessed, and we will meet tomorrow with some further consideration. Thank you.